Okay, class, picking up where we left off, we're on example 6. It says solve the system. Now we look here, we have y equals 2x minus 5 and 4x minus 2y equals 10. Now what I did here, I took each separate equation and found the x and y values. So I put in 0, 1, and negative 1. When x is 0, it gave us negative 5 for y. When x was 1, it gave us a negative 3 for y. And when x was negative 1, it gave us a negative 7. Now we go here. When x was 0, y was negative 5. When x was 1, y was 3. And then also when x was, actually, going back over this problem here, when x is 1, y is negative 3. That negative sign had disappeared, and I corrected that. Okay, so when x is 1, y is negative 3. And then when x is negative 1, y actually gives us a negative 7, as shown here. Now, when you go back up here and we look at our tables, if you notice here, our x values are the same and our y values are the same. When that happens, that is considered to be called all real number solution, which you will see down here. What you would see down here is just one line, because both of the lines will be exactly the same because they have all points in common. So when we scroll down here, our answer would be the solution is all real numbers and the system is called dependent. Now on the next page, we have the 3 cases for systems of linear equations in 2 variables. Case 1, intersect at one point. We show it here. No intersection or parallel lines. We show it here. These lines never cross each other. And then finally, intersect at every point, which was the last thing we did, which is here. It's typically shown by just one line. Now, we go down here to the next page. It says here, you plan to start taking an aerobics class. Non-members pay $4 per class. Members pay a $10 monthly fee, plus an additional $2 per class. The monthly cost Y of taking X classes can be modeled by the linear system. Non-members is Y equals 4X. Members is Y equals 2X plus 10. Now what I did here, I used 0, 1, and negative 1 for the Y equals 4X. When X is 0, Y is 0. When X is 1, Y is positive 4. When x is negative 1, y is negative 4, which is shown here. Now we go over here. We have our x and y chart. And then we substitute in 0 for x. And then when x is 0, y is 10. When x is 1, y is 12. When x is negative 1, y is 8. And I also use negative 2 here. And let me just get the answer first before I tell you why I use negative 2. So we have y equals 2 times negative 2 plus 10, which would be y is negative 4 plus 10, and y is 6. Now, the reason why I use negative 2 is because when we use positive 1, our y is 12. And when you look at our graph here, our graph and chart, the highest it goes up to is 10. So we want to keep something that's consistent with this graph here. So now we graph all of these points. Okay, so now what we have here is this here. During the first, the y equals 4x, we got 0, 0. We have negative 1, negative 4. And we also have 1, 4. This is that graph. Okay, now, using the other graph here, the y equals 2x plus 10. We have 0, 10, we have negative 1, 8, and we have negative 2, 6. And we graph that. Now, you can tell by the curve of these two graphs that they're going to intersect off of the graph here. So, when we go down here, it says interpret the coordinates as a solution in practical terms. One at this juncture, we cannot find the solution because we're graphing. We don't know how far to extend this graph. So what we would say is the solution to this system of equations is outside the scope of this graph. Now, we are about to start section 4.2 and 4.3, solving linear systems by the substitution and addition methods. Now, we're going to use these methods in order to solve problems like we had in the last section, which was 4.1. Remember, the last problem we did, we put that the answer was outside the scope of the graph. These two methods would take care of that. It says objective 1, solve linear systems by the substitution method. Use substitution to solve, and we have our two linear systems there. It says replace y in the top equation with the expression that represents y in the bottom equation, then solve for x. So basically this is what this is asking you to do. We're going to take the value of y here, which is 4x plus 7, and we're going to replace this y with this value here. So then we will have negative 3x plus 2 times, and we're going to replace this y with the 4x plus 7, and that equals 9. So we had negative 3x. We use the distributive property here. This will give us 8x plus 14 is equal to 9. Now we combine like terms. Negative 3x plus 8x is 5x plus 14 equals 9. We're going to subtract 14 on both sides, and we have 5x equals negative 5. Divide each side by 5, and x is negative 1. Now, it says here, once you know the value of x, plug it back into either of the original two equations to find y. What is the solution to this system? Now, what I'm going to do is, because I have a nice amount of room up here, I'm going to do the, well, first I need to get this to stop going. Again, since I have more room up here, what I'm going to do, I'm going to substitute in negative 1 for x up here. And what I'm going to do, I'm going to use this equation here, the first one. So the first equation was negative 3x plus 2y equals 9. That was the original equation. So we substitute in negative 1 for x. And we had negative 3 times negative 1, which is positive 3, plus 2y equals 9. Now we're going to solve for y. We subtract 3 on both sides, and 2y equals 6. Divide each side by 2, and y is 3. Now it says, what is the solution to this system? The solution is negative 1, 3. The answer that we get here is the point of intersection. Now we could go back up here. Now, of course, you can do this at your leisure, but let's take a look here. If we put in negative 1 for x here, that will give us positive 3. Well, let me do that. Let me take this equation here. We take negative 3 times negative 1 plus 2 times y is 3, and that's supposed to equal 9. Negative 3 times negative 1 is 3, plus 2 times 3 is 6. And we know 3 plus 6 is 9. Now that took care of the first equation. Now we want to do the second equation, which is the y equals 4x plus 7. So, we have what? Now we would finish this up by taking the second equation, which would be y equals 4x plus 7. Now we substitute in 3 for y, and we also substitute in negative 1 for x. So we have 3 is equal to negative 4 plus 7. And we know 3 equals 3. So this is the point of intersection, and this is also the solution to both of these systems. Now we scroll down here to the next problem. It says use substitution to solve. Now instead of what we had with the last problem, this time we have x that we need to substitute. So what we would do is this here. In this first equation, we have x equals 5y minus 7. So we'll put 5y minus 7 in place of this x. So it'll be negative 4 times 5y minus 7 plus 3y equals negative 6. Negative 4 times 5y is a negative 20y. Negative 4 times a minus 7 is a positive 28 plus 3y equals 6. Negative 20y plus 3y will give us a positive 17y plus 28 equals 6. But it's supposed to be negative 6. Now we subtract 28 on both sides. And we have 17y is equal to a negative 34. Now we need to divide each side by 17. Well, actually it should be a negative 17. We divide each side by negative 17. And our answer would be y is equal to positive 2. So now that we know what y is equal to, now we have to go back and solve for x. I'm going to use this first equation here, and I'm going to substitute in 2 for y. So we have x is equal to 10 minus 7. X is equal to 3. So our answer here would be x is 3 and y is 2. And you could go back and check this at your leisure. Now we go to the next example. Example 3. It says solve the following system using substitution. Above here it gives you steps to take whenever you have a system of equations where one of the variables is not isolated. This is what I would tell you to do. Look at both of these equations and ask yourself, if you're going to use the substitution method, which variable in which equation would be easiest to isolate by itself? So I would say the first one would be, and I would say get y by itself. So I would subtract 2x on both sides. 2x minus 2x is 0. We have y is equal to negative 2x plus 10. So we're going to take this value here for y, and we're going to substitute this into this second equation. So we will have 5x plus 3 times negative 2x plus 10 is equal to 3. So we have 5x minus 6x plus 30 is equal to 3. 5x minus 6x is a negative x plus 30 equals 3. So we will subtract 30 on both sides. And we will have negative x is equal to a negative 27. Now, we need to get the negative off of the x. So we would divide each side by negative 1. And we will have x is 27. Now, what we need to do is this here. We need to go back to one of the original equations, and we're going to substitute in 27 for x. So I'm going to go with the first equation. We have 2x plus y equals 10. So we will have 2 times 27 plus y is equal to 10. 2 times 27 is 54 plus y equals 10. Subtract 54 on both sides, and we will have y is equal to a negative 44. So our ordered pair and our final answer is 27 comma 44. And 27 comma negative 44. And we're done with that problem. On example 4, it says solve the following systems using substitution. You notice here we have x by itself. We have x equals 1 minus 4y, so we substitute that here. So we have 2 times 1 minus 4y plus 10y equals 4. 2 times 1 is 2. 2 times a minus 4y is a minus 8y plus 10y equals 4. Negative 8y plus 10y will give us a positive 2y. Now we subtract 2 on both sides, and 2y equals 2. Divide each side by 2, and y is 1. So now we could go through to one of these equations and substitute in 1 for y. So we have x equals 1 minus 4y X is equal to 1 minus 4 times 1.